Good morning to everyone. In microprocessor and microcontroller, I am Vigneshwari. In this video, we are going to see about the possible commands that works in the MASM compiler in 8086 microprocessor. But I am going to talk only about RCL and JNZ or JZ possible commands. There are so many instruction sets in 8086 microprocessors. Today I'm going to focus on only RCL the command and how an RCL command works and its invalid commands. Same that the similar to JNZ and JZ command, that is jump non-zero and jump zero commands. Before that, we will briefly deal about the RCL, that is the rotate left through one carry. This instruction rotates the mentioned bit in a register to the left side one by one such that almost the bit that is being rotated it is stored in the carry flag and then a bit in the CF moved as the LSB in the register. The syntax, the RCL register, the comma bits to be shifted. For example, RCL CH comma 1. For example, mm, and this is the code I have written, the code segment. This is all the instructions. We have to follow this. For that, move AX comma 1234H and move CX comma 01H and RCL AX comma CL. That is the informations. That is the data in 1234 will be loaded to the register AX, and then how many time it gets rotate is mentioned in a CX command. And finally the data move on to 1 and AX. let's um, let's run this in a DOS box. Mm, mount C colon slash 8086 C colon. I'm taking this name as an RCL. So masm RCL dot asm. There is the no invalid statement. So link rcl.obj, then debug rcl.exe. Let's run this. We can see that AX value is 2468. That is, it can be executed. For example, 1234 can be written in terms of binary digit, so that the first the 0 can be move on to one carry bit, and the one by one the digits get shifted, and then finally we get the answer AX is 2468. Next, we are going to see about the invalid RCL command. For example, move CL command 9, because CL is an 8 bit. Here the we count up to 9, so it is an invalid command because it exits an 8 bit operand. And another example for this is RCL AX comma 4. This is an invalid command. This can be replaced by move CL comma 04, and then AX can be rotate up to then count the 04. And example 3, the RCL content of BX comma CL. This is an invalid command. This can be replaced by First we have to move the content of bx to then another register, that is an ax. After that we have to rotate up to one cl value as we declared. The next command is JNZ and JZ command. That is JZ is jump if 0. The purpose for this command is the JZ instruction caches then a jump to be specified label if 0 flag is set. The 0 flag is set when the result of the last operation, that is the compare, subtract or XOR, is 0, the meaning that the operand are equal or the result is 0. For example, the syntax will be Z sum of the label. Same that for Zn Z jump if not 0. The purpose of this instruction is caches the jump to the specified label if the 0 flag is not set. 0 flag is cleared when the result of the last operation is not 0, meaning that the operand are not equal or the result is non-zero. The syntax is same as that the Z is a label, and it can be done by using the DOSBox variations. Before that, what are the invalid commands that is included in ZZ and ZNZ? For example, what are the invalid commands? These all are the invalid commands that are not works in a compiler. For example, ZNZ 5678H. This is invalid. Why? It expects the label. The ZNZ, after that we have to give only the label and not a number or an address or then a data. Same that say is 1234 which is an invalid, that is same, you cannot use any address instead of the label. And for example 3 says that this is also invalid because the jump address or the label, here the label is going to miss, so this is an invalid command. Here I am writing the code, that is by assuming that the ax and bx value to be then a 5, and here I compare both ax and the bx. If ax value is 5 and bx value is also a 5, if it is an equal, then the dx will be given as 0. For just for the demonstration we have to see that if both are an equal, then the dx, the register value will become as 0. If it is not equal, then the dx value may be considered as 1. Here we use that 4ch and 21h because the z is equal to 0 0, it does not works in some of the compiler, so I use these commands. Let's run in this code in a DOS box. There is the no error occurred in this program. So next link loop 1 Adobe. Next debug loop 1.exe. Let's execute by line. Here you see that if both are an equal, I already said that the dx value should be then a 0. Here we can clearly notice that the dx value becomes an 0. This value becomes 0. If it is an unequal, let's see this what happens. For example, I am taking an bx value as 7. Let's run this program. Here we can see that if ax and bx value are then same, the dx register will be then a 0. If ax and bx will be then a different, then the dx will be the 1. Here we can notice that the dx value is equal to 1. This is how the program get executed.